Hi, this is Victor and welcome back to my math tutoring channel. In that video, we'll try to solve that integral, which is cot to the power of 5x cosec to the power of 3x dx between pi over 4 and pi over 2. Yeah. As I said in all my previous trigonometric videos, whenever you have a trigonometric formula with the power to an odd number, try to make at least one of them to the power of an even number. And because all the trigonometric identity formula are to the power of 2. So let's change that. In that case, I'm gonna change both of them, the cot and cosec. So my integral become between pi over 4 and pi over 2 of cot to the power of 2. Actually, I'm gonna make it cot to the power of 4 x times cosec to the power of 2x multiplied by cot to the power cot x cosec x dx. So because cot to the power of 4 times cotangent to the power of 1 is cotangent to the power of 5, and cosec to the power of 2 times cosec to the power of 1 is cosec to the power of 3. But I wanted to make this to the power of 2, and I will make it now to the power of 2. I did it in 2 steps for you to understand better. So my integral become pi over 4 to pi over 2 cotangent to the power of 2x to the power of 2 times cosec to the power of 2x cotangent x cosec x dx. But I know from the trigonometric identity formula, cotangent to the power of 2x, it's equal cosec to the power of 2x minus 1. So I will replace this cotangent with this formula. So my integral become from pi over 4 to pi over 2. Instead of cotangent to the power of 2, I'm going to write cosec to the power of 2x minus 1, and all that to the power of 2 multiplied by cosec to the power of 2x cotangent to the cotangent of x cosec of x dx. Now I know that the derivative of cosec is cosec times cotangent. So I will take let u equal cosec of x. My du is equal minus cosec of x cotangent of x dx. So if you realize, my cotangent x dx is my minus du. So minus du is equal cosec of x cotangent of x dx. So now I can replace cotangent x cosec of x by minus du and the cosec by u. So let's do that. Because I want to replace the cosec by u, I need to change the boundaries of my integral. I know that the cosec of pi over 4, it's like 1 over cosine. It is equal to 2 divided by square root of 2, because like the sine or the cosine is square root of 2 divided by 2, so 1 over I have to flip it. But I want to multiply it by 1, and my 1 I want to write it in an intelligent way, which is square root of 2 divided by square root of 2. So this become 2 square root of 2 divided by 2. It become, I can simplify by 2, it becomes square root of 2. And cosec of pi over 2, it is, I know the cosine of pi over 2 is equal to 1. 1 divided by 1 is 1. So now I will rewrite my integral. Instead of pi over 4, I will write square root of 2. And instead of pi over 2, I will write 1. And my cosec, it become my u square minus 1 to the power of 2 times u square times minus du, because my minus du is equal to cosec x cotangent of x. I don't like the minus here, so all what I have to do is to flip the boundaries of my integral and get rid of the minus. So my integral become from 1 to square root of 2 to u square minus 1 to the power of 2 u2 du. And I know u square minus 1, it looked like a minus b square, which is equal a square minus 2ab plus 1. And in my case, my a is equal u square and my b is equal to 1. So u square minus 1 square become, between 1 and square root of 2, become u to the power of 4, because u square to the power of 2 is u to the power of 4, minus 2u to the power of 2 times 1, but I'm not gonna write times 1 because 1 is the neutral element of the multiplication, plus 1, all that multiplied by u square du. Now I will distribute my u square inside my parentheses, so my integral become from 1 to square root of 2 u to the power of 6 minus 2 u to the power of 4 plus u to the power of 2, and all that is du. And because of the minus here and the plus here, I can split it into 3 integral. So my integral become from 1 to square root of 2 of u to the power of 6 du minus 2 integral of u to the power of 4 between 1 and square root of 2 plus integral between 1 and square root of 2 of u square du, and there is a du here. And this is easy to solve. That become u to the power of 7 divided by 7 minus 2 u to the power of 5 divided by 5 plus u to the power of 3 divided by 3, and all that between 1 and square root of 2. Now I have to replace all u's by square root of 2 and then put minus and replace all u's by 1. So it become square root of 2 to the power of 7 divided by 7 minus 2 square root of 2 to the power of 5 divided by 5 plus square root of 2 to the power of 3 divided by 3 minus, and I open my parentheses, 1 over 7 minus 2 over 5, because I'm replacing u by 1, plus 1 over 3, and I close my parentheses here. So there is, I'll take out the parentheses from here. So now let's try to do the calculation. Actually, I did it for you. So square root of 2 to the power of 7 become 8 square root of 2 divided by 7 minus 8 square root of 2 divided by 5 plus 2 square root of 2 divided by 3. If you wonder, I took square root of 2 to the power of 6 times square root of 2 to the power of 1. This is how I get square root of, this is how I get this. And square root of 2 to the power of 6 is square root of 2 to the power of 3, and 2 to the power, it's 2 to the power of 3, and 2 to the power of 3 is equal to 8. And here, it is square root of 2 to the power of 5. So I took to the power of 4 first, times square root to the power of 1, and square root of to the power of 4 is 2 to the power of 2, times 2, it becomes 2 to the power of 3, and this is how I got my 8, etc. So minus, I'll keep this as 1 over 7 minus 2 over 5 plus 1 over 3. And my common denominator become 105. And here I have 120 minus 168 plus 70. All that multiplied by square root of 2 minus, and I put the minus beside my division, because it will be distributed to everything inside that fraction. So again, it's 105 the denominator, and I will have 15 minus 42 plus 35, and this become 22 square root of 2 minus 8, and all that divided by 105. And that would be the final answer for that integral. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.